Now, before we get started, let's take a look at what a rational equation might look like. Essentially, a rational equation is any equation where we see a rational expression inside of our equation. For example, the proportion equations that we were working with in Chapter 6 are an example of rational equations. Of course, rational equations could be a lot more complicated than the proportion questions we've seen already. So let's take a peek at some strategies that we can use to solve these kinds of equations. So I want you to recall that when we were solving our proportion type questions, what we did was we multiplied by the LCM of our two denominators. So, for example, if we have this question, 3 over x is equal to 5 over 2, a natural way for us to proceed is to multiply both sides by 2x, which is the LCM of our two denominators. Why do we do this? Well, because our denominators are going to cancel out with one of the factors inside that thing we're multiplying by. And then when we go to rewrite out our next step, we don't have any fractions anymore. So I'm going to work through a couple examples with you of more complicated rational equations where we use this strategy of multiplying by the LCM of the denominators. Let's look at the following example. 12 over 3x minus 2 is equal to 3. Now remember that over on the right-hand side, because we have the value of 3, we can think of this as a fraction over the number 1. This means that the LCM of our two denominators, 3x minus 2 and 1, is really just 3x minus 2. This suggests that if we multiply both sides by 3x minus 2, we can get rid of all of our fractions. Now we do have to be a little bit careful here when we are multiplying by a polynomial that has more than one term. You're going to see me put my expressions in brackets. That's because sometimes after we're finished our canceling step, we're going to have to distribute through in order to remove our brackets. So notice that by multiplying by 3x minus 2, the denominator is going to cancel over on the left-hand side, and we're going to be left with just the value of 12. On the right-hand side, we have 3 times 3x minus 2. So here's where we're going to have to expand through our brackets and distribute our 3. So here we'll get 9x minus 6. And now this looks like something that we've solved before. We can add 6 to both sides. This is going to give us 18 equals to 9x. And then we could divide both sides by 9. And this gives our final answer of x is equal to 2. Alright, let's take a look at our next example. Here we have x minus 6 over x minus 3 is equal to 2x over x minus 3. Now, of course, there's a couple ways to go about starting to tackle this kind of equation. You might notice that the two denominators of our fractions are the same, so you could add these two fractions together to start. If you don't like working with fractions, then I suggest multiplying by the LCM of your denominators. We treat this x as x over 1, so its denominator is 1 and is not going to affect our LCM. That means the only denominators we have are x minus 3. This means if we multiply all of our pieces, or all of our terms by x minus 3, we're going to get rid of all of our fractions. So I'm going to go ahead and insert an x minus 3 for all of our terms here inside of brackets. And notice that in our rational portions, the x minus 3's are going to cancel. And that's going to leave us with the following expression. We're going to have x minus 3 times x minus 6 is equal to 2x. Now we're going to have to do a little bit of work over on the left-hand side to expand through these brackets. So if we expand, we get x squared minus 3x. And now we could recognize this as a quadratic equation. So it's up to us to collect all of our like terms over on the left-hand side and set our equation equal to 0. So what I'm going to do first is subtract 2x from both sides. This gives us x squared minus 3x minus 6 minus 2x equals to 0. And if we collect together our two like terms of minus 3x and minus 2x, we'll have minus 5x. So from here, what we need to do is we need to factor our quadratic in order for us to solve this equation. So we're looking for two factors that multiply to give us negative 6 and add to give us negative 5. Those two factors are negative 6 and positive 1. Negative 6 times 1 equals negative 6. And negative 6 plus 1 equals negative 5. And it's from this last factored equation that we get our final answer of x is either equal to 6 or x is equal to negative 1. All of the work that we've done in our previous lessons to keep track of our restrictions is now going to be used here when we're solving our equations. So, the action of us multiplying all of our terms by the LCM removes our denominators from our question. This means that when we get to our final answer, we have to go back to our original starting question and determine whether or not our final answer makes sense. Sometimes one of our solutions that we get when we sub it back into our original equation causes a division by 0, in which case we're not going to want to include this particular solution in our solution set. In fact, these solutions are false solutions, and sometimes they're called inadmissible solutions. So, my recommendation is, as you're starting these kinds of equations, keep track of your restrictions at the very beginning. When you get to your final answer, double check and make sure you haven't gotten a value of x that conflicts with the restrictions that you have from the start. Looking at this example, let's try to figure out what our restrictions are before we begin trying to solve this equation. Looking at our denominator, we have that x plus 4 is not allowed to be 0. This leads us to our only restriction: x is not allowed to equal negative 4. Now that we have our restriction, let's go ahead and try to solve this by multiplying every term by x plus 4. After we've multiplied everything by x plus 4, we notice that the denominators of our fractions are going to cancel, and we're going to be left with x equals 3 times x plus 4 minus 4. Let's go ahead and distribute our 3 through the brackets to get 3x plus 12. And I'm going to do one more step on the right-hand side. I'm going to do 12 minus 4 for 8. Okay, from here, let's subtract 3x from both sides. This is going to give me x minus 3x equals to 8. Or x minus 3x gives us negative 2x in total. And if we divide both sides by negative 2, we get x is equal to negative 4. But we already know from the start of the question that we're not allowed to use the value of x equals negative 4 because this causes a division by the number 0. So in this case, we say that the equation does not have a solution because we're unable to put the value of negative 4 into our original equation. Let's go ahead and solve one more equation. Remember that first we want to get at our restrictions. So what we have to do is we have to factor the denominator of the fraction over here on the right. So think of two values that we can multiply together that will give us 8 and two values that we'll add to give us -6. Well, those values must be -4 and -2. So we could easily now write down our restrictions. We have that x cannot be equal to 2, x cannot be equal to 4, this one also says x can't be 4, and this one also says x can't be 2. So we have two restrictions here that we have to worry about. Now that we have our restrictions written down, let's go ahead and multiply all of our fractions by the LCM. Notice that our larger fraction has two factors in the denominator, x minus 4 and x minus 2. Our smaller fractions only have one of each of these factors in the denominator. This suggests that if we multiply by this denominator, x minus 4, x minus 2, we can remove all of our fractions. So I've gone ahead here and I've rewritten out our equation from above, and I've multiplied each of our terms by x minus 4 times x minus 2. Notice that we get some cancellations that happen, so we remove our denominator here, we'll remove our denominator here, and we'll also remove our denominator on the farthest fraction as well. Here's the equation that we get after we have removed all of our previous denominators. So I'm going to begin by trying to remove as many brackets as I can. I'm going to distribute through the x to get x squared minus 4x. Since there's no distribution to do in the second set of brackets, we can just write this down as plus x minus 2. Notice here that we have a quadratic equation. This means we need to move everything over to the left-hand side and set our equation equal to 0. I'm going to go ahead and combine my x terms. So we have -4 plus 1, that's -3x. And in order for us to move our positive 2 over, we'll subtract 2 from both sides. So that leaves us with x squared minus 3x minus 4 is equal to 0. And then we try to find factors of this quadratic expression, two numbers that multiply to -4 and add to -3. And those values are going to be -4 and positive 1. So this tells us that possible solutions are x is equal to 4 or x is equal to -1. But we do have a problem. We're not allowed to include this value of x equals to 4 was a restricted value at the very start of our question. This means x equals to 4 is an inadmissible solution. We're not allowed to take this as part of our solution. In this case, we're forced to conclude that x is equal to -1 is the only possible solution to this equation. Alright, my little epsilons, stay positive.